Okay, if you can't explain it, you don't understand. So make her explain it, Drew. So what would be helpful is if you work in the center of the table so that everyone can see what you're doing and can contribute to it. Okay, and Tayana, what were you writing about?
Well, I labeled A, B, C, D.
Okay.
And then I was going to put A, E, B is congruent to A, E, B because side, angle, side.
Okay.
Or it could be sides.
Wait, you're doing rhombus, right?
No, kite.
Oh, you did kite. Okay. So what do you have to prove? Let's back up here for the kite. What do you have to prove?
You have to prove that there are two sets of adjacent sides that are congruent.
Okay, good. Now what are the criteria that you have for the diagonals?
They have to be perpendicular. One of them has to be bisected. They intersect.
Okay, anything else? What about the lengths?
The generic one is like twice as long as ever for the generic length, right? Like the generic height.
Okay, I want you to stop thinking about kite as a real thing in life.
Okay.
So to make a kite, do the diagonals have to be the same length? Do they have to be different lengths? Did you experiment with that? Okay, why don't you fiddle around with that, because you have the three things. You have to consider the angle, and you've got the intersection, but you don't have the lengths part yet. As soon as you've got that, you can write your conjecture, okay?
Is congruent, okay.
And then if those two are congruent, then...
So we have to use the reflexive property for MQ. MQ is congruent to QM. And then for this one, we're going to have to say QO is congruent to OQ. And since this angle is congruent, so we have side angle side for every single one of them. And then we use the CPCTC. Right?
Yeah.
Okay.
What's the title?
Yeah, just say proving kites.
I don't care about decorations.
Oh yeah.
Okay, okay, good. I just want to see the map.
So, when we're writing our conjecture, does it have to be, like, when you're making a shape, or can it be, like, related to the problem with the sticks and the fastening at holes and stuff?
As opposed to...
So like saying diagonals or sticks?
Oh no, diagonals is better. That's the sticks thing was the sort of the launching idea, but the diagonals is the correct mathematical term.
So you can't really say that you're trying to fasten it at the same number of holes.
Oh right. And how would you say it if there weren't holes? What would you say?
Same distance from endpoint.
Great. Same distance from the endpoint. That's really good.
Okay then. And intersect at the same distance from the endpoint. From one endpoint.
And intersect.
At the same distance from the endpoint.
We kind of already proved that it's a kite, so I think we did something wrong.
You kind of are ready to prove that it's a kite, or you cannot prove that it's a kite?
We wrote that two sets of the two adjacent sides would be congruent. I wrote that all quadrilaterals would be congruent.
All what would be?
Sorry, I said that completely wrong. The two diagonals that intersect would be perpendicular, and just saying that, it automatically makes it a kite because there's no way it couldn't be a kite. It had those
Okay,
two.
and so, but that's what you need to prove, that there's no way it couldn't be a kite. That's what you have to show, step by step by step.
Okay.
That's what proving means.
Well, no, it's just, like, well, I kind of get it more now, but, like, it just seems like I'm saying what a kite is and then saying it's a kite. I'm giving it the exact properties of a kite and then saying it's a kite, but saying that all properties of the kite are given.
Are they given?
That's how we wrote it.
So if the properties are given, the perpendicular diagonals, that doesn't guarantee that it's a kite. You have to show why that makes it a kite.
Oh, okay.
You have to show why. You might have to use congruent triangles or something like that.
Yeah.
But in other words, it seems obvious to you, but it's actually not, unless you can use a mathematical reason why those sides. Like, do you know why those sides, these two sides are congruent?
mean,
Why the
yeah,
adjacent? Why?
because it's the what's it called? It's the opposite side of the right angle. You know what that's called?
Well, you can have lots of right angles, Ryan. The hypotenuse,
What are the giant rulers?
What's the name?
the hypotenuse.
Yeah, it's they're both the hypotenuse.
Just because these are opposite a right angle does not mean they're congruent.
Okay, I get it now.
We can do to help this get expedited.
The last thing I have left is that list.
The list.
The two bomb
The what?
Two bomb proof.
Oh, I wonder if one person could write on the statement and the other person could write the reason. Would that help?
Oh.
Could you both, two people write at once?
Can somebody do my hair at the same time?
We're starting to write the
one where we
proof.
cover
Good.
paragraph for
Wow.
2 columns.